All right, we got some new work on the bench here. We have two Alpines Mrv-1507s. These are old school amplifiers. These are probably 15, 20 years old. They superseded the Mrv-1505, which I think was a better amplifier. These were a little bit more delicate girls. If 1505 were almost bulletproof. You could beat the hell out of them and they survived. These things here, they were a little bit more fussier. I've seen a lot more of these come across my bench over the years, and with stupid problems. The 1505s, I have seen the inside. I have worked on the inside of them before, but it was because due to improper hookup or something stupid. It was never a component failure that I've seen. Like I said, I haven't worked on too many of them, but I've seen a lot of these. This is probably the third or the fourth one that's been on my bench, including these. So they were nice amplifiers. They were almost like, I think, 750 or 1,000 watts mono. Well, they're two channel amps, but they're bridgeable down to one channel, and these things were nice amplifiers. The one I got back probably about 10 years ago, I got off eBay, and I was told it was a good amplifier, and it ended up coming with a bad FET in it. And I changed the FET out, and it ended up sitting around in my basement for a while. And then my buddy bought it off me, and he ran it up, and he was having an issue with it where it was shutting down on him when he was turning it up. And I took the amplifier back. I looked in, and I had to just rebias the amplifier, and it was good to go. So, but these two amplifiers, I think they're gonna. I don't exactly know what's wrong with them yet. These are actually from another technician, a friend of mine, that has tried to work on them, and I think he just ran out of time. He doesn't have enough time to continue working on them, or he's fallen down the rabbit hole with them and he doesn't know what to do. I'm not entirely sure the story is yet. I think he's mentioned to me that there's some other issues with this amplifier. He probably just doesn't want to deal with it, or he just doesn't have the time. And I asked him if he had any projects going on that he put aside for a rainy day, and he says, yeah, I got two amplifiers. You want to work on them, be my guest. So I grabbed them off him, and here they are sitting on the bench. So figure, why not fix them up and get them back out get them back in use instead of sitting around rotting. So I'm just going to do one at a time here. I'm going to try and contact my friend eventually and find out where he's left off. But I'm just going to go through an initial inspection and see if I see anything that jumps out, any popped FETs or components that are burnt or blown up. And I think these amplifiers have pretty much already been mostly disassembled, so I don't see, because these panels are all loose and stuff inside, and I think it's almost ready to just start troubleshooting. So I'm going to flip it over and just do an inspection and see what we come up with. Alright, so I thought I would do a little overview of these amplifiers. These things are massive. They're probably almost 24 inches long by about maybe a foot wide. They're pretty big amplifiers. They're heavy too. They're a lot of beef on them. So these screamed. The only thing that I didn't like, that I didn't understand why they did this, is they ended up putting a fan on the 1507s, and the 1505s did not require a fan, and I've never had any issues with the 1505 shutting down due to heat. So I'm wondering if this newer design had some cooling issues that they ended up having to retrofit this fan into it, or they just thought it'd be a better idea for some reason. I just don't get it. But yeah, that always led to possibilities of either dropping stuff in there or water getting in there, moisture, whatnot, fan failure. And if the fan was required to keep the power supply cool and the fan failed, also fan noise. I'm not sure how noisy these things were, but I'm sure that they did produce some sound level that would probably be annoying if you had it inside the vehicle versus a trunk. So I'm going to pull one of these off the bench and put it aside, and I'm going to start disassembling at least one of these. I'm not sure if one's any better than the other to start with, so I'm just going to pick one randomly and go for it. All right, so we'll see in the next shot. All right, so well, it appears that it finally has happened to me. I have lost a block of video. My computer crashed at the end of the recording, and I lost a bunch of good stuff, but I'm going to bring it up to speed as best as I can. I did end up fixing most of the issues with this amplifier. There were some more issues that I'm going to go over right now. Apparently, that the technician before my buddy that had it had done some real botch work to this thing. I contacted my buddy and asked him about the stuff I seen in here, and he didn't know anything about it. So I can assume that whoever worked on this prior to my buddy should not be working on amplifiers. I'm going to show you what happened. What I did was I ended up hooking up my signal into the RCA input of the amplifier, and I was getting an output. I think hopefully I still have that video to show you that was working. The only thing that was wrong with that is the amplifier was saying that I had a ground float problem, which means there's the discrepancy between the ground of the RCA source and the RCA ground in the amplifier. So I went ahead and said, okay, I'm just going to ground the supply to the RCAs. So that should create the loop, and that should take care of that, and the light should go back green. Let's just say it didn't work out that way. I saw a nice big spark jump from my RCA plug to my jumper lead, and I scratched my head, and luckily I had the power supply limited to only a couple of amps, so it didn't hurt anything. It just kind of made a little arc mark on the RCA, which shouldn't have happened. So why did that happen? I was saying to myself, I put my meter on it, and I've had this all on video, and I lost it. I'm really bummed about that. I put my meter on the RCA lead, RCA shield to the ground of the supply, and I was getting 49 volts. I was getting rail on my RCA connector. So that was a huge problem. And I don't know if this also was lost, but there was a little bit of an odor emitting from this amplifier. It was very faint, and it was hard to find out where it was coming from. But it was just a little odor coming from the amplifier board section. And I couldn't figure out what was going on. Everything was working. I was getting my outputs on my oscilloscope. I tested it on my speaker. Everything was working, but something was starting to run away. I took my thermal camera out. I went and I found some transistors that were getting a little too hot, hotter than I wanted to see. And until that arc happened, I realized something is not right here. And I ended up going through all the FETs, and I actually found one FET that did not have an insulator under it. The tab of the FET was actually grounded right to the chassis, so that's where the rail came from. And I can show you that here on the microscope. I didn't have the exact insulators that came with the amplifier, but I had something that was good enough to sub in for now. Where are we going here? We want microscope cam. Okay. All right. This FET right here, there's still some crud in here, but yeah, this FET was just sitting on the aluminum heatsink with no insulator. And as you can see, the one that I put in there is orange, right? So it's easy to see that it's there. But look at the next one. You can't see it. You can't tell that the micro insulator is there or not. On this one, you kind of can. So because you can kind of see the step. Let's see if I can go over here and zoom down. You can kind of see the step in the insulator right here. That's where the insulator is. So it being clear insulators, I assume that all the insulators were under the FETs, because I would expect that whoever would have worked on this would have been conscious enough to put it back in if they had taken it off. It did not appear that they seemed to know what they were doing. So once I put the insulator back under there, the 49 volt rail voltage disappeared from my RCA plug. So let's go back to this here. Hold on. No, that's not the one I want. I gotta organize this list. This is getting a little cumbersome here. Yeah, that's where the 49 volt rail voltage was coming from. And after I replaced that, finally the amp turned on. I had a green light on. I grounded my RCA back up to the ground of the power supply again, and it did not spark. It did what it's supposed to do. The green light turned on. It finally said no. It finally said it was grounded properly to the RCA. My signals are working. I'm getting my signals out of the amplifier. What else here? I rebiased the amplifier, or I set the voltages back up. There's a few potentiometers here that you have to rebias some of the outputs. Set up the rail voltage adjustments. Everything's good. Looks good. But then I'm getting a power. Now I'm getting a power low indicator on the amplifier, which is supposedly below 10 volts. And I'm wondering why that is. It could be because of the Zeners I put in a little bit lower value than I should have put in there, but it's all I had to test this with. There should be 16 volt Zeners in there. There's 15 volt Zeners in there. Those are going to get swapped out as soon as I get 16 volt Zeners, but that could be the issue. Why? Because that feeds the positive and negative 15 volt rail to the through this whole board. It actually backfeeds it back onto the power supply. So, and there's a comparator circuit. I believe it's a comparator on the voltage I can't remember the name of it. The voltage well, why don't we just look at the print. This is it. Low battery detector. That's what I'm trying to think of. I believe it's comparing a voltage here, and I believe it has a 5.1 volt Zener. I believe that the op amp is fed off 4 and minus 8. Oh, I'm sorry, 8. Terminal pin 8 on this is one half of the op amp. This is the other half of the op amp. So the power rails are 4 and 7, and they go over to 15 and 14, which are the power supply rails for the 15 volt positive and negative. So now that those are low, I cannot rely on this calculation being correct in this area here. So I'm going to say that is probably what it is, but I'm not entirely sure yet. Let's go back down here to the amplifier section. So now that we have the signals coming out of the amplifier and everything looks clean, everything looks nice, we're going to do a thermal video of the amplifier running to make sure that we don't have anything running away, any FETs that are leaky, or any other issues on the power supply or the output transistors. I'm kind of hoping that everything is good there, because then that would just be a matter of solving the issue for the low battery detector. And like I said, I think I already know what that is. So I'm going to warm up the amplifier now. I'm going to put the power up the amp. Let's go to test equipment. All right, I'm going to power this amplifier back up. All right, the fan spins. Let's go to the oscilloscope. Make sure we still got both channels. Oh, yeah. Hook the RCAs up. Good. and good. Alright, so we're good there. Now let's go to the thermal camera and see if we can see any FETs that possibly are running away. Hopefully not. Alright, so we're in the power supply section now. Don't mind the reflections. That does disturb the image here a bit. That's not heat signatures. I'm going to turn MSX off because it does not work properly at this distance. Okay, a little bit of reflections. Everything looks good. Getting a heat signature there. That looks like it's off of a... what is that? Okay, that's a 1 watt resistor, so I would expect that to warm up. Everything looks good here on this channel. I'm sorry, this side of the power supply. Everything looks okay here. Alright, so now let's check the FETs of the amplifier section. Look good there. Let's check the other side. Now these are the regulator circuits for the plus and minus 15 volts. Those are getting nice and warm. That's normal. Now we'll check this side of the FETs. Ooh, what do we got going on here? This FET here is starting to get a little bit warmer than the rest, and possibly this. So there's something going on with this side of this channel of the amplifier. Let's take a closer look with the microscope, see if we see anything obvious. So let's go back to the microscope. All right, what's going on over here? All right, so these FETs. Right here, let's go to the let's get the multimeter here. Let's check, make sure we don't have any shorts or very low resistance. Alright, I get 20K. I'm not seeing anything bad about it here. No, I'm not seeing any shorts or anything. I'm going to compare it to another channel that's not warming up. No, I'm getting the same readings. Something is going on beyond the FET. Alright, let's take a look around this area, see if we see anything that's obvious. And I think you're gonna see something obvious. This is the botch that I think that the previous repair person, before my friend got it. And that's it right there. That is the Noble resistors. Well, it should be one resistor package. These are where the sources hook up to the transistor. I'm sorry, the source from the transistor hooks up to the resistor pack here. If you look at the channel that's next to it, there's only one there. I do not understand why there is two in super glue or epoxy and a crack. I don't know what's going on. That is kind of disturbing. If I had to guess, what happened here is that this channel had blown out before, because if you look at the MOSFET, you'll notice that this MOSFET has cut corners, and the channel next to it does not have that. Neither do the other transistors. So this MOSFET has been replaced before. So something was wrong with this area previously, and I could guess that that resistor had failed in some fashion, either shorted or opened, and caused that MOSFET to smoke up. And they replaced the MOSFET, but did not replace the resistor. What they looked like they did is they found another one and piggybacked it onto this one. That's not the right way to do this. You want to have, I don't know, see there's 3 pins in here. There's actually 2 resistors in this one package. There's a terminal here, a terminal here, a terminal here, and a terminal here. And there's a resistor between the terminal from this side to the middle and from the middle to this side. I think that this resistor will also have the same thing. I think what they did was they piggybacked it and paralleled this resistor, which will bring down the resistance for that channel. And I don't know what they did here. I really don't. I'm just guessing, but I'm pulling this out and seeing what's happening here, because that is just not correct. It just does not look right, and it should not be in there. All right, so I pulled out those 0.1 ohm noble resistors, and it appears that they're glued together and jumped across, and well, I'll just put it under the microscope and you can see. It looks like this is probably okay. It would have worked. I'm not really sure that this was the issue, but I just kind of don't like to see it. See, it was kind of jumped across, and it's still read like it was okay. They actually clipped the leads on the other component and just used the internal resistor on this one and the internal resistor on the other one. That would have worked. That should be fine electrically, but it just looks like shit. So I'm going to replace it with a single 5 watt 0.1 times 2 resistors in one package. It's basically what the original part was that was in there, and I got that out of this is why I always say keep your donor boards, because they can come in handy. You know how much these things are? I mean they're not super expensive, but go try to buy one. They're not they're hard to find, and if you do find them, you gotta wait 3 weeks from China. This come out of a piece of junk Sony Explode, and now I know why it's called that, because these pieces of crap do nothing but explode. Yeah, look at this. This is called an amplifier. Oh, okay. Quality? Shit. All right. That's how you can tell. That heatsink on the outside does nothing when there's nothing in it. I mean, wow, this is ridiculous. I mean, there's barely anything on this. It's just a piece of crap. I don't see. This is why people get tricked into buying this crap. But anyway, don't buy Sony amplifiers. They're horse shit. I mean, at least the Explode version was. So yeah, we're gonna throw this one in there, and I kind of assume that the FETs may have an issue. I would have replaced the pair of FETs, because I think maybe one went and then the other one maybe was partially and now all of a sudden the other one's taking the load. I would have replaced that in a pair. So we're probably going to end up replacing the pair of FETs that drive off of this resistor, and hopefully they'll share the load evenly once again. Alright, so what I did was I pulled the 2 FETs out and I tested them. I have a very basic tester, and it showed that the gate for the turn on the FETs was a volt lower on one versus the other. It was like 2.8 on one and 3.5 on the other. So I think there's a bit of an imbalance there. There could be some leakage. I'm not entirely sure. I would just replace the pair of them. But I don't have any in stock, so what I ended up doing was I just swapped the positions to see if the problem moved. If it doesn't move, it's on the board. If it did move, it's the parts. So here's what I got to hook up the thermal here, and we'll show you what I found. The problem moved. It moved to the left. It used to be on the right, the hot trace, the hot thermal. So I would think these FETs should be changed out as a pair, and just so to make sure that they're equal and balanced. As for the rest of the amplifier, everything is nice and cool and staying cool, and that's seems like the only one issue left on all the power components. Everything looks pretty good and consistent. So with that being said, I think I'm going to put this one aside and start working on the other one. I'm going to contact my buddy and see what he wants to, if he just wants to take it from here and put the screws back in it, change the FETs. I don't know if he's going to give me the FETs, whatever. I'll change them out. I don't care. But this thing needs a little bit of an overhaul. You know, it needs to be cleaned up. It needs the screws. So we're going to, you know, maybe I got to talk to my buddy, see what he wants to do. There's just a lot of stuff missing that should be in here, but it's functioning, it's working. So I'm going to kick this one aside and I'm going to throw up the other one. I'm probably going to make this a separate video on the second one. So I hope you guys enjoyed this video. It's a little long, but I kind of wish I had some footage here that I had lost to show you guys, because it was pretty good. I changing a few of the components, and yeah, I'm kind of upset that happened, but hey, it is what it is. All right, so have a good night, guys. We'll see you in the next one.